Hi, my name is Saad. I've been working in the Blue Yonder WMS space for far too long. I'm Executive Vice President with Smart IS, and we have a booth here. We would like to see you there. The topic that I'm going to cover today is about computer vision, image recognition, and how these domains we can utilize some of the technologies that are available today to support some of the use cases. So the way I would approach the topic is that first I would go over certain terms and terminologies so that we know what we are talking about and how does that impact today versus tomorrow, and then some challenges, and then I would go over certain use cases that we can use today with the WMS system. So first thing I want to just demystify is that AI, machine learning, these terms have been thrown around a lot. So I want to make sure that I'm clear as to what I am referring to when I'm talking about these terms. So essentially, AI algorithms versus traditional algorithms is simply the data set that they go by. So AI algorithms have a very high reliance on statistics. And in that respect, they are very similar to our human brain, how it works, right? If you have an apple, and you want to recognize that it's an apple, believe me, you are not computing its radius and temperature of its color, none of that. It is basically that image that goes into your brain, recognizes against other images of apple, and then you come up with a probability that you have an apple. And that's generally what AI algorithms would also do. So it basically would have a high reliance on statistics. And machine learning is in the same thing. We all are from IT world. We are familiar with the traditional cycle of requirement gathering, analysis. Then we go to development, deployment, and then the circle starts over. Then the new solution that has been put forth, you analyze it again. So essentially, if some part of that cycle are being done by a computer, then that becomes machine learning. So essentially, we need to demystify these terms, that these are essentially what we are all used to. So then what does it mean? That is simple. There are certain things which are becoming simple over time. And we can again relate to that simplicity, improvement of abstraction with general computers, right? So if you are my age, you know that the SQL was a great thing at one time, but what it was doing was improving abstraction. So AI also, as it becomes more abstract, it will become simple to use. But some domains in AI are very mature, right? ChatGPT might be a buzzword, but some domains are very mature. For example, computer vision is very mature. We have been uploading our photos to Google Photos for some time. It's very mature. It recognizes images very accurately. Then natural language processing, again, we are all used to that use case. It is also quite mature. Query optimization for databases, that they have been using heuristics for a long time. And those are all quite mature. So maturity is a subjective word these days, but yeah, but it has been used quite heavily. So what would it mean? As AI becomes more mainstream, these are the trends we would see. So systems would become data hungry, because statistics work only if you have a lot of data. You recognize that apple only if you had enough images of apple in your brain. If you didn't, then you would probably be biting over something which you shouldn't be biting over. SAS is again a very natural thing, that it's not an accident that everything is coming together in 2024 the way it is. SAS is also something which allows the software to have a lot of data. Learning algorithms would become quite common for existing problems. So you would see some of these heuristics becoming mainstream. Feedback loops are very important for machine learning, because otherwise it is difficult to use certain AI use cases within the mainstream, and if you cannot act upon the feedback that you got from your algorithms. And exact flows would become difficult to predict. And that, like, if you try to figure out how Google rank your search, it is very difficult to predict. And that is generally part and parcel of heavy reliance on data and a lot of data. People who might be coming from a database administration know that it's very hard to predict the exact query plan that your query would take because of heavy reliance on statistics and data. So if you are an early adopter, it poses certain challenges. First challenge is the complexity. The algorithms would become extremely complex in terms of trying to understand what they just did. And you can draw an analogy to Google search, simplest use case, but how did it rank it? It's extremely complex. And the systems would become closed, so you would have even less access to the data. And data security would be also a very big concern. So some of these challenges, for example, if you have a classic, highly regulated industry where you want to create test cases, even for a package application before you can use that. So just imagine how you would use if there's a new slotting algorithm came, which is based on AI, but you have to still test it, but its results are no longer that predictable because it's relying on your data. So that those kind of challenges you have to deal with. So it is important to think about those now. Maybe you have to think about the success condition is also a probability, that if I have a work, my work has this much probability of being the next work, but it might actually not be the next work because of some AI-based algorithms. But with that backdrop, I want to get into certain things which we can do today in terms of AI and machine learning, what is available today. And these are the three things I would be going over. One is computer vision or image recognition, document management, and using LLMs, which we can use today. So with computer vision or image recognition, one thing we have to just appreciate is that this is quite a mature domain. Again, mature being a subjective word with AI, how we use it. It is ubiquitous. We are all used to it. We have so far listened to the news on that as well, how it made mistakes, and how we are ourselves consumers of it. It is reasonably accurate, right? If I look at the quality of results, it's reasonably accurate. And the learning protocol is extremely simple, because if you used to Google Photos, it would often give you that is this person, this person. So that's basically the feedback loop it's doing. So either it is that image or it is not that image, so it's simple. But that's where we come into the next part, which is the crux of my presentation, is that we can utilize that to integrate into business use case. And that, again, cameras are ubiquitous, they're everywhere. All you need to do is take that image and then drive a use case which can help you. So this is some of the things we did so one of the use cases which I am especially interested in is cycle counting in a warehouse. Because what happens is that in some respects, you are forced to do cycle counts, but in some respects, they are not really helping during your picking and receiving cycle. So it becomes kind of a cost. But if a large number of cycle counts you can do easily, then it might save a lot of time. And we have already used certain strategies in the past, for example, count near zero and whatnot, that if something can be done freely and it can be counted against your counts, then you have saved a lot of resources. So what we said was, okay, what if we took an image of a location and use certain learning strategies? How good can we get? And what we found was quite interesting. So this is not a cleanest image of a location, but we were very easily able to teach it that these two are empty spots, these two are some inventory in those boxes, this is a location. So that level of complexity was not difficult to train, right? And our training model did not go exactly, it used the AI and machine learning strategies where we said, okay, we are going to teach you how to recognize it. And similarly, the same model, then we said, okay, how can we recognize that this is an empty location? Because again, counting an empty location counts as a count, right? So we were able to very accurately, with a reasonable accuracy, say that this is an empty location. And that is again a very same kind of model being taught, that, okay, what if there is something in those locations? What is a location? These are different dimensions of locations. So again, we were able to use simple teaching techniques to come up with those kind of models where we were able to recognize each one of those things with a very high accuracy. So then another use case which we had from experience was that if you're doing value-added services in a highly regulated industry, you have to make sure that the table that you're doing a value-added service is empty before you did it, right? That's a very fair ask. And for that, the solution that you have to come up with then is to say maybe one person looks at it, the second person comes and signs it, the table is empty, or you come up with a very expensive laser to figure out that the table is empty. Well, how about the camera, right? So very accurately, we were able to figure out that this is a table which is empty and this table has a pen, right? And it is actually better than using a laser or something like that because it can recognize a flat thing on it. If you put a label on it, it would be able to recognize that there's a label on it, so you should not be doing your VAS service yet. And you have a documented proof as well. If you're doing something around safety, again, same thing. You can recognize if the person is wearing a hat, how many people are. If you have certainly an organically a congested work area, you can figure those out quite accurately, and the cameras are there anyways. So that was quite good. Similarly, for a draw plot management or yard management, to figuring out that which truck is coming in, nobody has to scan it. There's a license plate on it. And that accuracy is very high. And with a good camera, you can read it quite accurately. You can figure out where the empty spaces are. So all of those coming together, you have a very easy integration point with the existing infrastructure or hardware that you might already have. And this is something in our offshore office that we have a video playing, and we were able to train it to say which ones are the bystanders, which ones are the players, and it is able to count how many people are there, and with a camera which is there already, right? So again, this kind of thing can be integrated into something like, okay, if there's a congested space and you want to suddenly, for whatever reason, and you want to stop people from going into that space, it is possible. It is not even a very complex problem to solve with existing technologies or hardware that you might have. So computer vision ends up being that concept that is almost ready to use if you want to integrate it into prime time. But one thing which we have to worry about it, if we are using in business, then accuracy needs to be high. And for accuracy needs to be high, we need to incorporate machine learning, which I said earlier that all we need to do is that as we see prediction, then we have to be able to act on that and train it further to say, okay, this is how I need to include it. But again, that should not be a new domain. We are all used to those kind of cycles that, okay, I see it, or this is what it did not recognize properly, I would train it further. So it ends up being a relatively simple protocol to implement. So that is one domain that I wanted to go over, that where it is relatively, if you have a camera, you can implement this in your business environment. A second thing which I want to go over is document management. We have all written those documents, but when it comes time to use them, they are hard to find, or then there is not enough information there to make them usable, right? So this is something which we were quite surprised to see how good today's technology is with respect to document management. So we pretty much upload the documents, and it is able to figure out quite accurately that, so I uploaded the whole WMS solution summary, and then I asked it, how do I process an order of this type? It told me quite reasonably that these are the 4 steps in your document that you would use to do the document type. We have all seen Blue Yonder's release notes, right? Those long release notes. So I uploaded that and said, okay, what is important in these release notes? And it was able to tell me exactly, these are the modules, this is the stuff inside those modules. So it was able to decipher quite a lot of information from there. So then the next thing which I wanted to go over was the LLMs. So this is something that we have, you can come to our booth and we can show you that we have in most WMS system or anything, we have requirement for ad hoc access. And we use page builders, DDAs, whatever, to provide certain data. And as soon as we provide the data, it becomes obsolete after that because they needed something more. So what we did is that we created a Teams channel or a ad hoc channel, chatbot, either way, but we can ask it a question in natural language. And on the other end, we have just given it a repository of our business, like Mocha commands or business services that are available. And very accurately, we are able to predict, give the answer, like show me the items of this order, and it gives me that data. And similarly, it can show me as a pie chart as well, the same kind of data. So, and this becomes quite an easy thing. And many of those use cases where you were saying, I need this page builder or I need this data to provide to somebody, those become very simple to do. So overall, and then you can utilize, because this is running as a Teams in cloud, you can easily integrate heterogeneous information as well. You can superimpose your orders with zip codes and the weather in those zip codes. It's like not even an interesting problem. It's a relatively simple problem because it's coming from the cloud and you can integrate it. But underneath it, to make it work, because a lot of these LLMs require work to be from the cloud. So that is where this is our ecosystem, that how we have created in there, that we can use multiple LLMs that we can, and then that is running in the cloud. So then we have a product called Oogie, which then allows us to go inside the firewall to then execute the result and give it back in real time. So that is basically our diagram to support LLM, where we can give you the results from there. So this kind of implementation, you please come by our booth so we can show you how these simple answers can be given for these kinds of use cases. So overall, that's what smartifying this kind of a concept is, that we can utilize the LLM to integrate with your on-premise systems or BY cloud systems, and then we can bring multiple data together from other systems or from the cloud, and then we can do in-depth analysis. And we can also do evolving prompts as well, and we can keep context as well. So you can get some orders and say, okay, what was wrong with these orders? So that kind of stuff can be done quite easily as well. So my basic conclusion is that we need to be ready in terms of what is coming our way. But there are a lot of things which is available right now, and with many of the hardware which might be there sitting in your warehouses, and we can utilize those to our advantage and solve some interesting problems with this. So basically, if you have any questions, we can do it at this time. I have a couple of minutes. So you're asking if the documentation I showed was that where document your answer, and yeah, of course you can ask the question in reverse and it will provide where the answer is in the documents as well. So but that's all available through Copilot and whatnot easily. Yeah, you can go in both directions. Well, thanks for your time. My time is almost up.